The listing for metal-clad duplex connectors does not include non-metallic cable, which is also known as NM cable or Romex. Therefore, the only cable that can be used in a duplex BX connector is BX cable. An installation where two Romex cables are run through a duplex BX connector is most likely not compliant with electrical codes and could potentially be a fire hazard. The reason for this is that a BX connector is specifically designed for BX cable and is not intended to accommodate NM cable. Attempting to force NM cable through such a connector can lead to damage to the cable's jackets and insulation. This damage compromises the integrity of the cable, increasing the risk of electrical shorts, arcing, and ultimately, a fire. The proper and code-compliant way to enter a panel with NM cable is to use an NM cable connector. These connectors are specifically designed to accommodate NM cable, ensuring a secure and proper connection without damaging the cable. These connectors typically feature a clamping mechanism that grips the cable's outer jacket without putting excessive stress on the conductors or insulation. Using the correct type of connector is crucial for maintaining electrical safety and preventing potential hazards. When selecting connectors, it is essential to verify that they are listed and labeled for the specific type of cable being used. This information can typically be found on the connector's packaging or in the manufacturer's specifications. Always refer to the National Electrical Code, also known as NEC, for specific requirements and guidelines related to cable installations and connector usage. The NEC provides detailed instructions on the proper methods for installing electrical wiring and equipment, ensuring that installations are safe and compliant with industry standards. Furthermore, it is important to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. These professionals have the knowledge and experience necessary to perform electrical installations safely and correctly, minimizing the risk of electrical hazards. Firstly, always turn off the power to the circuit before working on any electrical wiring. This is a fundamental safety precaution that helps prevent electrical shock. Secondly, use properly insulated tools that are designed for electrical work. These tools help protect you from electrical shock and prevent damage to the wiring. Thirdly, inspect the cable for any signs of damage before installing it. Damaged cable should be replaced to prevent electrical hazards. Fourthly, tighten the connector screws properly to ensure a secure connection. Loose connections can cause arcing and overheating, which can lead to a fire. Fifthly, protect the cable from physical damage by routing it properly and using appropriate supports. Damaged cable can create electrical hazards. Sixthly, follow the manufacturer's instructions when installing connectors and other electrical components. This will help ensure that the installation is done correctly and safely. Seventhly, if you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical work can be dangerous, and it is always best to err on the side of safety. It's important to understand the different types of electrical cables and their applications to ensure proper and safe installations. NM cable, commonly known as Romex, is a type of electrical wiring used in residential buildings and other dry locations. It consists of two or more insulated conductors surrounded by a non-metallic sheath. NM cable is typically used for branch circuits and feeders that supply power to lights, outlets, and appliances. MC cable, or metal-clad cable, is a type of electrical wiring that consists of insulated conductors encased in a flexible metal sheath. MC cable is used in a variety of applications, including branch circuits, feeders, and services. It is often used in commercial and industrial buildings, as well as in residential buildings where greater protection from physical damage is required. BX cable is an older type of armored cable that is similar to MC cable but has a different type of armor. BX cable is no longer commonly used in new installations, but it may still be found in older buildings. Understanding the ampacity of electrical conductors is crucial for safe and compliant electrical installations. Ampacity refers to the maximum amount of current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor size, material, insulation type, and the ambient temperature in which it is installed. The National Electrical Code, or NEC, provides tables and guidelines for determining the ampacity of conductors in various conditions. NEC Table 310.15b16 is a commonly used table that lists the allowable ampacities of insulated conductors rated up to 600 volts based on their size and insulation type when installed in raceways or cables or directly buried in earth. It's important to note that the ampacity values listed in NEC Table 310.15b16 are based on specific conditions, such as an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit, and no more than 3 current-carrying conductors in a raceway or cable. If the actual conditions differ from these assumptions, adjustments or corrections may be required to determine the appropriate ampacity for the conductor. For example, if the ambient temperature is higher than 30 degrees Celsius, a temperature correction factor must be applied to reduce the allowable ampacity of the conductor. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, an adjustment factor must be applied to account for the increased heat generated by the conductors. It is also important to consider the termination temperature ratings of electrical equipment such as circuit breakers, switches, and receptacles. These devices are typically marked with a temperature rating such as 60 degrees Celsius or 75 degrees Celsius, which indicates the maximum temperature that the conductor terminations can withstand. The conductor ampacity must be selected so that it does not exceed the termination temperature rating of the equipment. Using a conductor with an ampacity that is too high for the termination temperature rating can cause the equipment to overheat and fail, potentially leading to a fire. To ensure safe and compliant electrical installations, it is essential to consult the NEC and other relevant standards and guidelines to determine the appropriate ampacity for electrical conductors. It is also recommended to consult with a qualified electrical engineer or electrician to ensure that the installation meets all applicable requirements. Furthermore, understanding voltage drop calculations is essential for ensuring efficient and reliable electrical power distribution. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. The NEC recommends that voltage drop on branch circuits should not exceed 3%, and voltage drop on feeders should not exceed 5%. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where volts drop is the voltage drop in volts. K is the direct current constant, which is approximately 12.9 ohms circular mils per foot for copper conductors and 21.2 ohms circular mils per foot for aluminum conductors. I is the current in amps, D is the one-way distance of the circuit in feet, and Cm is the circular mils of the conductor. The circular mils of a conductor can be found in NEC Chapter 9 Table 8. To minimize voltage drop, you can increase the size of the conductor, reduce the length of the circuit, or reduce the current flowing through the circuit. It is also important to use high-quality conductors with low resistance. In addition to ampacity and voltage drop, it is also important to consider the grounding and bonding requirements of electrical systems. Grounding refers to the intentional connection of electrical equipment and circuits to the earth, providing a path for fault current to flow back to the source and trip a circuit breaker or fuse. Bonding refers to the connection of metallic parts of an electrical system to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements include the use of grounding electrodes, grounding conductors, and bonding jumpers. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. Also, understanding the different types of overcurrent protection devices is important for protecting electrical circuits and equipment from damage due to overloads and short circuits. Overcurrent protection devices include circuit breakers and fuses. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overload or short circuit occurs. Fuses are one-time devices that melt and break the circuit when an overload or short circuit occurs. Circuit breakers are resettable, while fuses must be replaced after they have blown. The NEC provides requirements for the selection and installation of overcurrent protection devices. These requirements include the ampacity of the overcurrent protection device, the interrupting rating of the overcurrent protection device, and the location of the overcurrent protection device. It is important to select the appropriate overcurrent protection device for the circuit being protected to ensure that it will properly protect the circuit from damage. Furthermore, understanding the different types of wiring methods is also crucial for safe and compliant electrical installations. Wiring methods refer to the different ways in which electrical conductors can be installed and protected. Common wiring methods include conduit, cable, and raceway. Conduit is a rigid or flexible metal or plastic tube that is used to enclose and protect electrical conductors. Cable is a factory-assembled group of insulated conductors that are enclosed in a sheath. Raceway is a metal or plastic channel that is used to support and protect electrical conductors. The NEC provides requirements for the selection and installation of wiring methods. These requirements include the type of wiring method that can be used in different locations, the size of the wiring method, and the support requirements for the wiring method. It is important to select the appropriate wiring method for the application to ensure that the electrical conductors are properly protected. Also, understanding the requirements for electrical boxes and enclosures is important for safe and compliant electrical installations. Electrical boxes and enclosures are used to protect electrical connections and devices. They are typically made of metal or plastic and come in a variety of sizes and shapes. The NEC provides requirements for the selection and installation of electrical boxes and enclosures. These requirements include the size of the box or enclosure, the type of box or enclosure, and the location of the box or enclosure. It is important to select the appropriate box or enclosure for the application to ensure that the electrical connections and devices are properly protected. Remember to always consult the latest edition of the National Electrical Code, local amendments to the NEC, and any other applicable codes and standards for specific requirements and guidelines related to electrical installations in your area. These codes and standards are designed to ensure the safety of people and property, and it is essential to follow them carefully. In addition to the above, consider the following best practices for electrical safety and code compliance. Always use listed and labeled electrical equipment. Listed equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Labeled equipment has been marked with the manufacturer's name, model number, and other information to help identify it. Ensure that all electrical work is performed by qualified and licensed electricians. Qualified electricians have the knowledge and experience necessary to perform electrical installations safely and correctly. Licensed electricians have met the requirements of their state or local jurisdiction to practice electrical work. Obtain the necessary permits before starting any electrical work. Permits are required for most electrical work to ensure that the work is inspected and meets code requirements. Follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Inspect electrical systems regularly for signs of damage or wear. Damaged or worn electrical systems can create electrical hazards. Repair or replace any damaged or worn electrical systems promptly. Be aware of electrical hazards and take precautions to avoid them. Electrical hazards include electrical shock, electrical fire, and electrical explosion. Never work on electrical equipment while it is energized. Always turn off the power before working on electrical equipment. Use properly insulated tools when working on electrical equipment. Insulated tools help protect you from electrical shock. Wear appropriate personal protective equipment when working on electrical equipment. Personal protective equipment includes safety glasses, gloves, and footwear. Be aware of the location of underground utilities before digging. Contact your local utility company to locate underground utilities before digging. Do not overload electrical circuits. Overloaded circuits can cause fires. Use extension cords safely. Do not use extension cords as a permanent wiring solution. Do not run extension cords under rugs or furniture. Keep electrical equipment dry. Water and electricity do not mix. Teach children about electrical safety. Children should be taught about the dangers of electricity and how to avoid electrical hazards. If you have any questions about electrical safety or code compliance, consult with a qualified electrician or electrical inspector. These professionals can provide you with expert advice and guidance to ensure that your electrical systems are safe and compliant. By following these best practices, you can help prevent electrical hazards and ensure the safety of yourself, your family, and your property.